Okay, it's definitely recording correctly.
It's recording. See.
Yep, that's my gold mic, which is that little guy. Okay. All right. So the focus of this discussion is how do we manage file access permissions? How do we protect files so that they can only be accessed by people who should be able to access those files. For some reason, when I restart the computer, the projector decided to clip the sides of the screen again. Okay. I only have one single account here. Oh, I remember now. When I did this on the video, I was using a virtual machine, which has nothing to do with my live image. So that's why I have to redo the whole thing, which is perfect. Okay. So this is our regular user, and the first thing, if you want to do this experiment, you have to change to root first, because we are going to add like a few accounts here. The first account I'm adding, I'll just call that TAU. We'll just call that TAC. Okay, so TAC is my personal account on this particular persistent partition. Okay, and I'm going to add another account, and I'll just call that hacker. Okay, so as the name implies, the hacker account belongs to someone who likes to snoop and just sniff around and see if they can find anything interesting. Okay, so now we have three accounts. We have the default user account. I have TAC as a personal account for myself, and we have hacker as an account representing someone who likes to snoop around and see if they can look into other people's folders. Are we doing okay so far? Okay. So what I'll do is I'm going to change the account of the shell to TAC. So from now on, I'm dealing with my own account, my personal account here. And what I want to do is to just create a file first, a regular file, touch test.txt. Okay, touch is the easiest way to create an empty file, because all it does is to create an empty file, in this case called test.txt. And the way I know that is because I can ls and it shows that text file. But on top of that, I can also use ls-l so I can know a little bit more information about this file. Now let's take a look at these different fields here. There are several fields that are particularly important. This is the name of the file. That's not a big surprise. This part here is the last modification time of that file. If I change this file, if I edit it and save it, this time or this timestamp will change. This part here is the size of the file in number of bytes. It's 0 bytes because the file is empty. The rest is a little bit cryptic. Okay, how come we have two tags here? Isn't it enough to say that this file belongs to TAC? Well, as it turns out, exactly, there's one user owner and there's also a group owner. Every file has two explicit owners and one implicit owner. The two explicit owners, the first one is the user owner. A user is basically someone who can log in to the system, but it also has a group owner, and a group is not necessarily some name that you can use to log in as. But in this case, they're exactly the same, and that's the default when you create a file. There's also a whole bunch of cryptic stuff on this side too. Okay, this bunch of cryptic stuff here. Well, what this is the first letter is referring to this file, and if it is a special file, it will have a particular letter. Now, if it is a dash, that means this file is just a quote-unquote regular file. The next three letters, RW dash in this case, are the permissions granted to the user owner of this file. In this case, the user owner is myself, TAK. The next three letters, which is R dash dash at this point, refers to the permission to the group owner, which in this case is also TAC as a group. And the last portion which is also r dash dash, refers to the implicit owner of this file, which we just call others. Others refer to users who is not the user owner, which is myself, or a member of the group tag. Okay, are we doing okay so far? Okay, so what we can do, well, or what I can do is to change the ownership of this file just a little bit to make it interesting. Or better yet, I'll make a folder first. So I'll just make a folder called tester, okay, test directory. And I'm going to move the file inside the directory because I want to show you later on what you can do with directories or how you can protect a directory. So we go to the test directory and we look at the ownership of the file, and I want to change the ownership, and particularly let's change the group ownership of the file. I don't want me, TAK, as the group owner anymore. I want disk, DISK, as the group owner. Or floppy, most of you have experience with floppy and not disk. Okay, so we'll pick one of those two as the new group owner. The command that you use to change ownership of a file is called chown, CHOWN, which is the short abbreviated form of change owner. If you want to change the owner, which is the first part here, TAK, you can say, if you want to change it to root, you can say root. If you want to change the group owner at the same time, you have to use a colon to separate the user owner from the group owner. So in this case, if I want to change the group owner to disk, this is the way to do it. And then you just name the file. But this command will fail because a regular user does not have the permissions to change the ownership of a file. So if I press enter, it will just say operation not permitted. Well, that means you have to change to root to perform that operation. So in this case, let's not change the user owner. I still want to own the file. I will just go ahead and change the group ownership of the file. If you just want to change the group ownership of the file, then you have to start with a colon and then the name of the group in order to change just the group ownership. So in this case, we'll change that and get out of the root account or the root shell, and ls-l this time will show us that the file now still has tag as the user owner, but the group owner is now switched to disk. Are we doing okay so far? How to change the ownership of the file. Okay, so let's go ahead and now I'm switching back to root again, and this time what I want to do is to add myself to the group disk. I will also add user to the disk group, but I'm not going to add hacker because I want a user who is not a part of the group so that we can test what's going to happen to that user when we change permissions. Are we doing okay so far? Okay. All right. So it's a good time to start up another shell. And in this shell, I'm going to change user to, I'm already user though, so that's perfectly fine. And you will find that in most Linux systems, you can actually change the home folder of somebody else. In this case, I can change to the home folder of TAC. I can actually display the content. It's actually in dark blue, which is testdir. And if I go to testdir, I can actually see the file. Okay. So let's go ahead and do something here, and okay, let's go ahead and put some content into this file. Okay, so we'll go ahead and test. Oh, maybe we should do this with the other account. What do you think will happen when I try to edit this file when I log in as user? Let's look at the permissions again. Tag is read-only. It's read-only because of the middle part of the permissions. Okay, this is the permission to the file granted. This is the permission granted to the group owner disk. Now, user is a member of disk, which means user also has these rights or permissions to the file, but it does not include writing. So when you try to change the file, Okay, let's say we just want to append something to the file. Okay, so something, and we just append that to the file test.txt. It does not let me do it because I don't have any permission to do it. As a group owner, we only have read access to the file. On the other hand, if I want to show the content of the file, that's not a problem because I have read access to the file. Are we doing okay so far? Let's start up another one. Mr. Hacker. So I'm going to change to the hacker account here. And we'll just say, okay, let's see what Mr. Hacker can see from his account. So as hacker, I'm going to change to the folder tech. And ls, not a problem. I can see the content inside the home folder. I can change directory to testdir and look at that content too. And guess what? I can also look into the content of that file. Okay, but remember, hacker is able to do that not because of the middle r dash dash, but because of the rightmost r dash dash. The reason why that is the case is because hacker, one, is not the user owner of the file. He's not tech. And he is also not a member of the group owner, which is disk. Okay, so that makes hacker the third category of users, which is others, O-T-H-E-R-S. Okay, are we doing okay so far with this? So let's just say that I want this file to be readable to myself for sure, and I also want it to be readable to anyone who is a member of disk. Okay, because all of those members I can trust. But I don't want anyone else to have read access to the file. So that means I have to change the permissions to this file, or we call those mod bits to a file. The command to do that is called chmod, change mod, or change mode bits. Okay, and we want to specify others, which is a lowercase o, and we specify a minus here, which means we are removing a permission, and we are removing the read permission to it. Now, if you want to be really sure that no other permissions are granted, you can always say remove read, write, and execute. Even though the file did not have write and execute to begin with, it's not a problem. You can always say remove more than what the permissions are already currently set as. And then we just specify the file, and then we can use a ls-l to confirm that. You can see that the r dash dash is now changed to dash dash dash, which means others, anyone who is not the user owner or a member of the group owner, has no access to this file anymore. Now let's double check. Go to hacker, and cat text.txt doesn't work anymore because I have just lost my read access to that file. But what about ls? Hey, I can still see that there is a file called test.txt. I just cannot read it. Okay, are we doing okay so far with limiting access to a particular file? Okay, that's fairly easy. Now let's move on to folders, because folders is definitely a little bit more complicated than the other one. Okay, first of all, how do we know the permission of the folder itself? Well, tag, that's pretty easy. ls-l and a dot, because a dot always represents the current working directory, which is also called the current folder, right? Well, not quite, because when you do that, it will only display the content of the current working directory, but not the permission of the working directory itself. So what you need to do is to add the D option in addition to L. So when you say ls-ld dot, that means I want to show the details of the directory itself, but not the content of the directory. Okay, is that part okay? Okay, so when we press the enter key, you can definitely see that this time it shows something that's a little bit more interesting. What you cannot see is a little dot here. Once again, because it's a folder, it is in kind of dark blue and you cannot see it on this screen, but there's a little dot here. You see the timestamp, which is perfectly fine. We know that the timestamp has to be there. And then strangely, it has a size. A folder has a size. Well, guess what? In Linux, everything is a file, including a directory. A directory is basically a file that serves as a phone book, as an index to other files. So as a result, a folder also has its own size. As you increase the number of files inside a folder, this size will also increase. As you change the file names to be longer and longer and longer, this size will also increase. We can see that a folder also has a user owner as well as a group owner. A file also has permissions to the user owner, it has permissions to the group owner, and it also has permissions to others. But there's one more thing. You can see that the first letter of a folder is a D, which means this is not a quote-unquote regular file, this is a directory. D stands for directory. Any questions at this point? No questions? Okay. Now it's a good time. This is a good time to talk just a little bit about the X flag. Okay, the little symbol X here. Now, what does that mean? Execute for regular files. Okay, it actually has different meanings to different things. When you're talking about a regular file, X represents executable. Okay, this file is an executable. But when you use this flag on a folder, it means access. Okay, traverse. Okay, the correct term to use is traversable. The folder is traversable, which basically means it is accessible. Okay, so let's apply this flag to a regular file first. Okay, so we'll just go ahead and create a simple script. In my video clip, I actually use something that is really useful, which is a script to start your virtual machine. So I don't have a virtual machine here, but that's okay. I'll just go ahead and start VM, start virtual machine.sh. The extension actually does not matter. Linux does not really rely on the extension to tell the operating system what kind of file this is. But I just want to use the extension .sh to mean that this is actually a shell script. The first line is shebang /bin/bash. It is not required. Okay, if you're just writing a very simple script that has no conditional statements and nothing special, you don't need to use this because any shell would be able to run the content. So you don't have to specify, oh, we need bash, or we need C shell, or we need just regular shell, because any shell will be able to handle the content of this file. On the other hand, in the cisn120 class, you're writing more complicated scripts, and in those cases, the syntax of different shells can be different. So in those cases, you do have to say, okay, which shell should we use to interpret the content of the file? And this line becomes more useful. But at this point, if I miss this line entirely, hey, not a problem. And that's because to start a virtual machine, we just have to say kvm, and in the simplest case, you just have to say hda is that one file, vm1 in the folder vm1. I don't even have vm1 as a folder in here, but most of you do. And then you specify hd1.img. either qcow2 or raw, depending on whether you have done the conversion or not. Okay, and this is just a regular text file. So when you want to run the file, right now, if you run it as // and then start.sh, it doesn't let you do it. Oh, I misspelled it, that's why. vm.sh. Kept mistyping it. Okay, there you go. Okay, the file name is fine, but there's no permission to execute the file. Now you guys will tell me and say, but Tack, there's a little shortcut. You told us that we can use just dot and then the name of a file, and it will run it. Well, it actually ran it, except I don't have the image file. That's why I complained. But it actually ran the content of the script. This will work only if you have a script to play with. If you have a binary executable, this won't work. Because what dot says is feed the content of this text file as if it is typed on the keyboard. If it is a binary file, it's not going to work. So that means it is much better off if you learn how to use the executable bit, the X bit, to this one. So if I want to change the file to have executable permissions, then I can say chmod. Now, depending on who you want to grant the executable permission to, you can specify the user owner and the group owner just by combining those two into one little bunch, and then say +X. So this means add execute permission to both the user and also the group owner of the file. Leave the others alone. Okay, don't even touch others. And then just specify the file name, which is startvm.sh. And then when you do ls-l again, you can see that the user owner now can execute the file, so can the group owner. But as far as others is concerned, this is read only. Is that okay so far? Yes? Okay, excellent. So that's basically, well, just to make sure that we understand what that means, when we say /, this time it will even autocomplete, because the bash shell understands that anything with an executable can be executed. So when you say / and then press the tab key, it will automatically go find files that are executable in the current folder, which is really handy. And obviously when I press enter, it tries to start up the virtual machine, but since I don't have that actual image file, it just come back and say, well, I cannot find the image file, and it cannot start the virtual machine. So that's what the X bit means to a regular file, and most of you should know that from cisn120. But what if we apply that flag to a folder? In other words, when we say ls-ld, the current folder, remember there's a little dot here, it just cannot see it because it's in dark blue. Now this part is a little bit interesting because, hey, we have read access to the folder. I have, as a user owner, I have write access to the folder. Isn't that enough? Why do we need the X bit to this folder? The best way to understand this is to use an analogy. A folder is a container, so I would look at it as a lockbox. Okay, so you kind of imagine that you have a little lockbox, and that's a folder. The R bit means, is it transparent? Can I see the content inside the lockbox without unlocking it first? If you see the R bit here applied to a folder, that means the lockbox is made of transparent plastic. Okay, I can see clearly, oh, there's an apple in the lockbox, there's a book in the lockbox, and there's also a pencil in the lockbox because of the R flag here. Well, if the R flag means the box is transparent, what does it mean when we have the X flag when we are talking about the lockbox or folder? The X bit means I have a key to this lockbox. Okay, I can actually unlock the box and touch the items inside the box. Are there any questions at this point? Because I know it can get confusing from here on. One controls, the R bit controls whether you can see what is inside the box. The X bit controls whether you can actually touch the items inside the box. Or, even a better analogy is the R bit is the light switch in a room. Okay, you can turn on the light and you can see through the window what is inside the room. The X bit is the key to get into the locked room. So with a key, you can walk into the room and actually get stuff. Is that okay? The room analogy actually works better because now you can have something like this. Okay, so let's go ahead and set up our group permission to be a little bit strange. But before we can change the group permission, we have to change to the root account first. So we'll go ahead and change the group ownership, the group ownership, to this again, and we want to change that to the current folder, like that. Okay, is that okay? Does everybody understand what I just did? So if I do ls-ld dot, you can see that this time, or this, when I use the root account, it doesn't do the color highlighting, so you can see the dot now is owned by disk as a group owner. Okay, so that's the same as a regular file. There's no magic here. Okay, now I switch back to tag as a user. So what we'll do is we'll take out one of the two bits. Okay, we'll take out either the R or the X bit, and then find out what is the effect to a person who is a group owner. Okay, so we'll go ahead and take out. Which one do you want to take out first? Do you want to take out the light switch, or do you want to take out the key first? Take out the light switch. All right, we can take out the light switch. So we say chmod group owner now do not have access to read the folder. Okay, and then do an ls-ld to the current folder, and you can see the change is from here, which is r-x to just --x. What does that mean? Well, that means you have a room.
If you have access to the room, you can't really write to the folder, you know?
Well, yes, you lose the light. Okay, you lose the light switch, but you can still open the door because you still have the key to open the door. All right, so let's see what this means. Let's switch our shell and pretend that we are user. Now, user is special because user is a member of disk, and disk is the group owner of that file. So that means the --x permission is now applicable because we are just user. Okay. So the first thing we want to do is to say, well, can we still see the content of the file? Oh, we cannot see the content of the file anymore. I think that may be because we did something else. Permission denied. We can still ls. Oh, I took out the X bit instead of the R bit. Is that what I did? I took out the R bit and still have the X bit. That's not right.
So it doesn't mean that you can get into the directory and see the contents. You just can't view.
I should still be able to access the content of the file as regular user. So, oh, you know what? I know why. It's because I have to log in and log out again as user. Remember, when you change your group ownership, you have to get out and get back in again. And I'm not sure whether SU will do the trick. Maybe. Let's try that. SU user. And go to home tag tester, and I should still be able to look at the content. Okay, it does work. Okay, so why is this happening? I just took out the R bit to the folder and just only have the X bit remaining. How come I can still access the file?
You got the key to the file.
Because I still have the key to the room. I just cannot see my way into the room anymore. On the other hand, if I knew exactly where to find an item, I can still do it in the dark. Okay? Is this clear to everybody? Because I know it is confusing. How come we can still do this? I mean, it doesn't make any sense. Okay? So now, we don't know what else is in the room. Okay? We know the test.txt is in the room because we did the experiment, but we don't know what else is in the room. For instance, we don't know that startvm.sh is in the room because when you say ls, which means show me the items of the current folder, it doesn't do that anymore. The light switch is gone. You can no longer turn on the light of this room to see what is in the room. On the other hand, if you already knew that a particular item is in the room, you can still find that item in the dark. Is that okay? Because this can be confusing, because the next thing we'll do is to flip it. We'll enable the R bit, but we'll disable the X bit, and then find out what it will do to the user. So let's go ahead and do this here. And this time I'll use another way to specify chmod. We'll use the equal symbol here. In other words, I am not adding a permission, I'm not removing a permission, I'm specifying exactly the permission to the group owner. So in this case, I just want to specify the R bit, and we change that to just the current folder. Okay? So now let's see what we can do and what we cannot do as user, which is a member of disk, and this is the group owner of that file. First of all, let's see whether we can ls. Doesn't seem like we can do a ls, but that's only because we're in the current folder, and the current folder is test.testdir. If you go up one level and then say ls testdir, it actually works, sort of. Okay. In other words, right now we have a light switch. You can turn on the light switch and say, oh, there are two items in this room. One is called startvm.sh and the other one is called test.txt. What about this? What about ls-l testdir? In other words, I want to find out more detail of the items in this room. That doesn't work anymore. You can see that the command was able to find out that startvm.sh is a file inside this folder, test.txt is a file in this folder, but we know nothing about those files now. Because in order to know the attributes of a file, you have to be able to access the file. You have to be able to touch the file in the room. But since we don't have the key to the room anymore, we can no longer actually go in and touch these items. Are we doing okay so far with this? So the R bit is the light switch, and you can imagine there's a window you can see into the room. If you have a light switch, you can turn on the light and find out, okay, what items are in the room. The X bit is the key into the room, so you can unlock the door and actually go into the room and touch stuff.
Window shopping. It's like window shopping.
It's like window shopping. Yep. Okay. So now let's talk about the R bit. Okay. We will see what the R bit can and cannot do. So let's go back and turn on the X bit too, so that we go back to the default of R-X, because that's the usual way. It's really seldom that you will find a folder with only the R or the X bit. Most of the time, R-X go along together. Okay. Let's think about the X bit. The W bit. Now, at this point, I can do an ls-l testdir, and we can actually see, the files, and we can see that with test.txt, as far as the group owner is concerned, is read-only. Is that correct? Okay. So now let me go back to TAC again, and this time we'll say chmod g plus w dot, which means I'm adding the right permission to the folder to the group owner. Is that okay? And then we say ls-l, ls-ld dot, and we can see that the group owner can now read, write, and execute the folder. However, as far as the individual file test.txt is concerned, it is only read-only to the disk owner. Is that okay? So the folder is read-write, but the item itself is read-only. Here's the question. Can I delete the file as user?
As user?
As user. Can I delete the file? Okay. The point of confusion is it seems to be, they seem to be conflicting, because the file itself says it's read-only to the group owner disk, but the folder says it is read-write and executable to the group owner disk. So the question is, if I want to delete the file, what permission do I actually need?
Executable, right?
We need executable for sure, because when you're deleting something, you need access to the item.
You can delete it.
I can delete it, because remember, the folder is nothing more than a catalog of what is inside the room. If you remove the reference from the catalog into an item in the room, that item is gone. Okay? So even though I put a big lock on the item so I cannot, change the item, the catalog or the link from the catalog to that item, I can change that. If I can remove that link, then the item is no longer, reachable by anyone, and therefore it will be gone. So just to be sure that this is something that we can do, we'll now go ahead and delete test.txt. Oh, whoops. I'm not in the right folder, so let me change to tester first, and then remove .test.txt. Now, when you try to remove something like that, it will give you a warning. The warning says rm remove write protected regular empty file test.txt, and it's asking you to specify yes to confirm. The reason why it gives you a warning is not because you cannot remove the file, it's just that, hey, maybe this is not what you want to do, because the file itself is read-only. Alright, so if I can remove the file, even if the file is read-only, exactly what does that do when I say a file is read-only? What is protected, with writing through the file, changing the file itself? Okay, in other words, if I say vi test.txt, you can see the vi automatically recognize that the file is read-only, which means I cannot change the file, but I can still delete the file because the folder lets me delete the file. Okay, so this is really important. When you turn on the W bit of a folder, even if individual items are protected from being changed, the other person can still destroy it. They cannot change it, but they can destroy it. Here comes another question. Can user create a new file in this folder?
Yeah. Yes.
Absolutely, right?
Right.
So that means as regular user, as user, I can now delete test.txt, and I can create another test.txt and say this is created by user. That is bad, isn't it?
You just changed the file.
I just changed the file. Exactly. Okay. Now, when you change a file like this, what are the permissions to that file? Who owns that file? User, right?
Yeah.
You can see that this file test.txt is no longer owned by TAC or disk. It is owned by user only. As far as TAC is concerned, what do you think TAC? What is my access to this file from over this shell here? What can I do to that file?
TAC has no access if he's not part of that.
Well, I'm considered others, right?
Yeah.
I'm considered others because I am not user and I'm not a part of the group user. So that means
So you can
I'm read only.
Right.
Okay. So that
You
means
can switch it back. You do the same thing.
so that means if I try to vi to it, it is read only to me now. So that's why it is tricky. You got to be careful about this sort of thing. So the next question is, well, yeah, this is all kind of theoretical and kind of interesting. Yeah, but who would be so stupid to make a folder read write to many people so that this kind of problem can happen to it? Has anyone been to Power lately? What on Power is read writable to everybody? /temp. The temp folder, as a temp folder, it is read writable to everybody. So that means what we just saw here can potentially happen to the temp folder. If it's not for one really special mod dit, that would be like the nightmare of security.
The sticky bit,
The sticky bit, exactly. The sticky bit states what?
that nothing can be, even though it's read and writable, the file can't actually be changed.
It can only be deleted by the owner of the file. Exactly. So someone cannot do a switcheroo like what I just did. Because a switcheroo can be really bad. What do we store in /temp anyway? I mean, why is that such a big important item?
log file.
Well, we have some log files, but by default, what does PHP do to the /temp folder?
That's still every time it uses.
But what does it put into the /temp folder? PHP, web pages, stuff like that. Cookies. Okay, session cookies. So if you have session cookies stored in /temp, and you have the same server used by multiple people, different companies perhaps, they can now see each other's cookies, and they can also change the content without the sticky bit. They can actually change the content. So now you're opening up a big security hole because now someone can hijack somebody else's session. Okay, I'm a legit customer of Wells Fargo. Okay, so I just logged into Wells Fargo, do my online banking and stuff. Okay, but Wells Fargo is not rich enough to have its own server. It is sharing its server with Mr. Hacker, right? So Mr. Hacker can now go to /temp, find out all the cookies created by Wells Fargo, find out the session ID of those particular sessions, and you can program that into special browsers so that your browser now has the same cookie. Mr. Hacker can now withdraw money from my account. Bad things, okay? You don't want that to happen. That's why the sticky bit is important. This is also why if you take a web class, especially CISW 410 or 420, the web scripting classes, make sure the cookies are not stored in /temp. Bad idea, very bad idea. It's doing that by default, but it's not a good idea. Okay.
Now you'll be posting all the same screencasts as well.
Sorry?
You'll be posting this screencast as well.
Yes, this is all still being recorded. Let me double check. Yep, it is still being recorded. All right. So now there's one more thing to talk about. Okay, just one global thing to talk about. Let's take a look at /home/test_testdir/startvm.shell. Okay. All right. Oh, let's lose the -L too. All right. Nothing too special here. In order to be able to access this file, in order to get to it so that you can read it, change it, or execute it, what I have just told you is that every single folder here, home, tag, and testdir, they must allow user to access. The X bit must be on one way or another. Okay, do you see what I'm saying? In order for the user to access the file /home/tag/testdir/startvm.sh, every single folder, every single one of these three folders must have the X bit turned on for user, one way or another. Now, what do I mean by one way or another? Let's see what I mean by one way or another. Let's start with home. Okay, home. This is once again we cannot really see the dark blue here, but that's /home right here. Okay. Why does user have executable permission of this folder? Through what? I mean, user is not root. It's not the user owner. User is not a part of the group root. I mean, no one is dumb enough to add someone else to the group to the root group. But guess what? I'm others. User is others, and the X bit is turned on for others. Okay, so user has no problem with having the X bit turned on with /home. Let's look at the second level, ls-l -ld /home/tag. This is the second level. Same thing. User is not the group, is not the user owner. User is not the group owner, but user is others, and I do allow others to have execute permission to /home/tag. Let's look at the third level. The third level is /home/tag/testdir, and this time we have these permissions. So the question now is, which one actually applies to user? Now, this is also a trick question because, well, I guess it's not too much of a trick question.
The others permission.
No, it's not others, because user is a member of disk.
Oh.
Okay? User is a member of disk. Okay, now let's do this a little bit differently, and I'll do something like this. What does that mean? What have I just done?
There would be moves.
Nothing.
Right. Right.
Okay, in other words, the group owner now has absolutely no permission to the current folder. Okay, ls-ld would confirm that. Okay, the group owner now has no access to this folder. So as far as the group owner is concerned, it has no access to this folder anymore. So the question now is, do I still have access to items inside testdir? What do you think? The big question is, okay, the big question now is, we know something seems to be, we know that user is not tagged, right?
Right.
So we know that I cannot get the X permission by user owner. User is a part of the group disk. Okay? But the group now has absolutely no permission to this folder. But hold on a second here.
You got others here.
Others still have access to it. So the question now is, do you think user can go through others to get this X permission to this folder?
Yeah.
Yes.
The answer is no. Okay? Because as far as user is concerned, user is not others. User is a member of the disk group. Okay? Now how do I confirm that? Well, it can be easy to confirm. I'll just try to access one of the items inside the folder. I'll do an ls-l of the folder and see if I can see details of those items inside that folder.
Once you become a part of the group, you're no longer others.
That is correct. And you can see that I can no longer get to it. Okay? So others is not a fallback mechanism. Okay? If you are the user owner, then the user owner permissions and only the user member permissions will apply to you. The group owner does not apply to you anymore. Others do not apply to you anymore. If you are not the user owner, but you are a member of the group owner, then only those 3 bits apply to you. Others do not apply to you anymore. Only if you are not the user owner or a member of the group owner, then and only then the other permissions will apply to you. So this is really strange. Okay, this kind of permission is really strange because we are allowing hacker to access the file, but not the group owner. So that's that's unusual. Okay, but you can make it happen, if you specify the bits like that. Okay, so the rules are kind of confusing because most people would think, oh, if the group permission does not let me access the folder, maybe we can just fall back to others because others can access it, but it doesn't work that way. Okay.
So the only way the user he would have to not be part of the
There's no
group.
affiliation whatsoever.
Right. Oh, specify the dot. So once I turn those permissions back on, I can once again look at the content inside that folder. So any questions about this? Now, this is important. If you just look at what I did here, this means that if any one of these 3 levels, if user loses the X bit or uses the X permission in any one of these 3 paths, then user can no longer access startbm.sh. Okay, it only has to be just one of these 3 folders.
Any level.
Any level, and and then the item will no longer be accessible. Okay. Are there any questions of all the stuff that we have talked about so far? Is that confusing? I think some of it is actually confusing or counterintuitive, but until you run the experiments, you cannot confirm that one way or another. Questions? No questions?
You said something earlier about the sticky bit.
The sticky bit, yes. Okay. The sticky bit applies to folders too. And what the sticky bit does is it only allows the user owner of a file to delete that file. Because you have just seen that user was able to delete a file that belonged to tab. Okay, and it's only because the folder itself has write permission. So that's not the same thing, because now they can do a switcheroo. So I thought it's the same file that I had earlier, but the file is actually changed. So in order to use the sticky bit, you have to go to chmod, and chmod, as the man page is a really long man page, and I just look for sticky, and the sticky bit is lowercase t. So you can specify, basically O plus T, to /temp, and that will turn on the sticky bit for that particular folder. Let's go ahead and do it. Let's do this. Well, before we do it, we'll confirm what it is already set to, because it might have the sticky bit turned on already. You can see it is already turned on. RWT. So let's go ahead and do the same experiment here. In other words, I will, as tag, I will create a file in /temp. Okay, so we'll say this is tags file. Okay, so tags put a file in /temp, and as user, I will say, hey, from an early experiment, I find out that as long as a folder has write access, I can go in and delete files and create my own version of that file. So the first thing I would do is to confirm that text file is here, and also double check the permissions to that file. All right, okay, so that file belongs to tag, but at the same time, as far as /temp is concerned, everybody has rewrite access to it. Okay, so as user, I'm going to do a trick on tag. So I would go ahead and try to remove that file, because I know VI is not going to work, because the file itself is read only to the group member and also read only to others. So I know VI is not going to work, but I know the other trick, I can remove the file first and then create another file of the same name. That doesn't work anymore. Remove write protected regular file, and I say yes, and then it says no, it still cannot do it. And that's because of the sticky bit. The sticky bit basically tells the file system and say it is a special case. Only the user owner of a file can remove the file from the folder, even though the folder says read-write access are both granted. Okay. Any questions about this one? Let me give you one last trick question here. Let me switch back to root, and you can tell me what this will do. As root, I'm saying chmod O-W /temp. What do you think this will do to /temp? Oh, I didn't mean that. O-R. We tried the O-W already. We basically cannot change the content of that folder. So what about this one? O-R. What would that do to /temp? Well, we lost the light switch, so that means we can no longer see what is in the folder. But if you know exactly what you want to do or what file you want to access, it's still there. If you want to create files, you can still do it. Well, let's try it. Okay. So now I can say, in as tag, I will say, well, since I know that file, now tab as an autocomplete does not work anymore, because remember, the folder is no longer readable. I cannot use the tab key to autocomplete, because I can no longer turn on the light switch and say, oh, which item starts with TAK? Well, I cannot, there's no light switch anymore. The room is dark. But on the other hand, I still remember the name of that file. It's called tagsfile.txt. I can still edit it. As far as I'm concerned, the file is still there, and it is still rewritable, so I can do everything that I normally would do to that file. What about this? What about text other file? Can I create a new file? Not a problem, because as long as I have write access to it, I can delete, I can create, not a problem. But let's take a look from Mr. Hacker's perspective. Mr. Hacker likes to poke around and see what other stuff is in the system, right? Let's see what else is in /temp, so I can mess up other users. That won't work anymore. Now, on the other hand, if Mr. Hacker knows that there's a file called text file, he can still see it. Because the X bit means that you can still go into the room to access the items. You just cannot
See what's there.
exactly. You lose the light, to see what is in the room. But if you know ahead of time that there is such an item in the room, you can still find it and actually access it.
So you can read it if you know it's there.
Sorry?
You can read it if you know it's there.
Correct. It just makes it slightly more secure, because now you can just poke around and find, oh, this file looks interesting. Let's see what's in it. But you don't even know whether that file is there or not. Okay. So one more test case, and we are done with this module. Okay. So let's see. The current folder is set to r-x. Okay. And let's turn back on the R bit for group. Okay. So we'll do a chmod g plus w dot here, so that the regular user, okay, let me just off stagger this a little bit, so it's the border is too thin, and that's why it looks kind of confusing. Okay, so as far as we are concerned here, now we can create a file, right? User creates this. Okay, file created by user. And I just saved the file. Okay. Now we go back and do a ls-l, and we can see that the file that I just created is here. It is owned by user owner user and group owner user, and only user has read-write access to it. Now, as tech, I'm going to turn off the W bit of this folder as far as G is concerned. The group is concerned. So the group can no longer make changes to the folder itself. Is that okay so far? The big question now is, if I switch back to user, do you think I can still change the content of this file? Let me re-describe the situation. The folder is read_rx only as far as user is concerned, but the file is rw as far as the user is concerned. So the question is, can I still change it?
You're talking about if the folder's read only.
The folder is read and access only.
But
No
the
write.
file's read write.
The file is read-write as far as user is concerned. Okay, so let me just double confirm that.
Yes, you can.
Okay, so user creates this file.txt. As far as the user owner is concerned, it's still read-writable. So the question is, can I go in and make additional changes to the file? The answer is yes. Okay, just because you cannot change the catalog that links to the file doesn't mean that you automatically lose the ability to change the file that is linked from the catalog. So we lost the ability to delete files. We lost the ability to create additional files, but we haven't lost the ability to change a file that I own already in that folder.
So you can edit an existing.
I can still edit it. Yep. Yep, I can still edit and say, see, I can still change it and go back and confirm the change is sticking. Okay. So it is very important to separate permission to the folder containing a file from the permission to the file itself. So are there any questions about all these bits, special permissions and stuff like that? We haven't really talked about switch user ID and switch group ID. Those are kind of more advanced topics, and we don't have to touch on those, at least for now. Any questions about file permissions and stuff? Okay, so what I'll do is I'm going to recreate a homework assignment. There's one already online. I hope nobody has really gotten started with
They
that.
told me not to.
Yep. So okay. So nobody has started on that one yet. I'm just going to make it a little bit easier, so that I can, because on one hand, I want you guys to be able to do it at home. On the other hand, I want some way so you can show me that you accomplished, what needs to be accomplished in the homework assignment. So I need to think of a way to do it. I'm pretty sure I can use a script to, automatically check that you have done what needs to be done. So a script can automatically go in, poke around, and see which file is still accessible, which file is not. So I'll do that, later, tonight sometime, so that you will have that homework assignment later on. But the next project, after this topic, we have to go back to, actual, networking, and then we have to set up. Even with this one, you have to set up networking. Unfortunately, I don't have a virtual machine with this user account anymore. Maybe I do. Because what I want to do is to show you how you can open up multiple terminals to a single virtual machine. And I can do it. Okay, I can do this. Alright. So what I'm going to do is to pretend that you are getting into your virtual machine. I don't have one set up right now, so I will use the live image itself to create an additional virtual machine inside here. Okay?
Are we gonna stay on the same video?
Yes. Or do you want to separate it? I can separate.